So we've already looked at a lot of different properties of logarithms, and we're going to look at a couple new ones in this section. So logarithms are technically exponents. And if we look at our transformation, which we've been working with, log base 8 of 64 is equal to 2. We can transform that into 8 raised to the 2 is equal to 64. So if you look at the expression 8 raised to 2 is equal to 64, you could technically replace the exponent 2 with log base 8 of 64. And I can do that just because if you look at this statement right here, 2 is equal to log base 8 of 64. So what that means is anywhere you see a 2, you can replace that with log base 8 of 64. So I can replace this 2 with log base 8 of 64. And then 8 raised to log base 8 of 64 is equal to 4. This is a true statement. And this is really just to show that because they're technically exponents, the rules of exponents can be translated into new rules for logarithms. So let's just look at x squared times x cubed is equal to x to the 5th. When I multiplied my like bases, I wanted to add my exponents. So I'm changing a multiplication problem into an addition problem. If I have x cubed divided by x squared, I'm subtracting the exponents. So I'm changing a division problem into a subtraction problem. If I have x squared cubed, if I have power to power, I'm actually multiplying my exponents. So I'm changing an exponent into a multiplication. So you'll see we have our transformation rule here, and then we have 3 new rules. We have the product rule, quotient rule, and power rule. So let's look at each of these. The product rule, we're taking a logarithm with 2 things that are being multiplied on the inside and changing it to 2 logarithms with an addition on the outside. So we're changing a multiplication problem into an addition problem. For the quotient rule, we're taking 2 terms that are being divided on the inside and breaking it up into 2 different logarithms with a subtraction sign between them. So we're changing a division problem into a subtraction problem. And then lastly, for the power rule, we have an exponent, and we're bringing that down to the main level as a coefficient. So now that's changing the exponent into a multiplication problem. So before we use these rules, I want to first prove some of them. So I want to prove the product rule and really show where it comes from. So what I want to do is I'm going to let x equal log base b of a and let y equal log base b of b. My next step is to transform these. So if I transform them, this is going to be b raised to the x is equal to a, and b raised to the y is equal to b. Next, I'm going to multiply both sides together. So if you take the 2 left-hand sides and multiply them together, you get b to the x times b to the y. And then if you multiply the two right-hand sides, we get a times b. Okay, so looking at the left-hand side, these are like bases and we're multiplying them, which means we're actually adding the exponents. So that left-hand side is equal to b raised to the x plus y. Okay, my next step is I want to transform back. So I want to transform back to logarithmic form. And this will give you log base b of a times b is equal to x plus y. Okay, so let's look back at what we're trying to get here. We're trying to show the product rule. So we're trying to get this statement to show up. And we have the left-hand side. We have log base b of a times b. And we just need to get it to be equal to log base b of a plus log base b of b. So again, we have the left-hand side. We just need to get the right-hand side to look like that. And it's kind of tricky how we do it. We actually just look back at our original statements. So if you look back at the original statements, x is equal to log base b of a, and y is equal to log base b of b. And those are the two things that we want to have there on the right-hand side. So I can actually just replace those because they're equal to that. So I want to replace the x and the y. So the x I'm going to replace with that, and the y I'm going to replace with that. So I now have log base b of a times b is equal to log base b of a plus log base b of b. So now this looks exactly like the product rule that we have there. So we have proven where it's come from. The proof for the quotient rule, we're not going to do that, but essentially it's very similar to this proof.